RDX, HMX, and perchlorate are common and often commingled contaminants on military ranges worldwide. Extensive laboratory research has shown that bacteria can biodegrade these compounds under anaerobic conditions, typically using a carbon source as an electron donor and growth substrate, and the contaminants as electron acceptors. This ESTCP project investigated the feasibility of using a passive emulsified oil biobarrier to jointly treat RDX, HMX, and perchlorate in groundwater on an active range. In addition to the emulsified oil, which serves as a long-term carbon source, a slow-release buffering reagent was added to increase groundwater pH. The natural pH at the site, which averaged 4.6, was too low for the biodegradation of perchlorate to occur based on both treatability study results and previous data on perchlorate-degrading bacteria. A 100-foot biobarrier was placed perpendicular to the flow direction of the contaminant plume by injecting emulsified oil and buffer into a series of 20 injection wells spaced on 5-foot centers in the shallow alluvial aquifer. Dissolved explosives, perchlorate, and other relevant parameters such as total organic carbon, or TOC, pH, dissolved oxygen, anions, and oxidation reduction potential were monitored over time. After biobarrier installation, the pH increased to greater than 7 within the biobarrier and to 5.6 down gradient of the barrier. Dissolved oxygen and oxidation reduction potential decreased, as did concentrations of both nitrate and sulfate, which also serve as microbial electron acceptors. During the study, greater than 90% reductions in RDX, HMX, and perchlorate were observed within the barrier and in a transect of wells installed as far as 40 feet down gradient of the barrier compared to up-gradient groundwater. The initial concentrations of the target compounds were 104, 15, and 36 micrograms per liter for RDX, HMX, and perchlorate, respectively. The highest percent removal of all compounds occurred when the TOC in the groundwater was greater than 20 milligrams per liter. A second injection of emulsified oil was conducted 600 days after the initial injection in order to increase the TOC in the aquifer, which had declined over time. The second injection again resulted in a dramatic decrease in RDX, HMX, and perchlorate, each of which had rebounded somewhat as the emulsified oil substrate was consumed and organic carbon declined. Some nitroso breakdown products from RDX, particularly MNX and TNX, were observed immediately downstream of the barrier, but these products generally decreased to below detection limits further down gradient. First-order rate constants of approximately 0.1 per day were observed for all three contaminants. Dissolved metals, including arsenic, also increased in the wells immediately adjacent to the barrier, but attenuated as the plume re-aerated in down-gradient regions. Biobarrier installation and sampling was performed during scheduled range downtime and had no impacts to ongoing range activities. The field trial suggests that an emulsified oil biobarrier, with pH buffering where necessary, can be a viable alternative to remove explosives and perchlorate from shallow groundwater on active ranges.